Hello, my name is Dr. Gabriel Ordornez, and I'm a professor emeritus and principal investigator in the Faculty of Medicine and Surgery at the University of Santo Tomas in Manila, Philippines. I'm also the director of the Ordornez Laboratory, currently tasked at researching the physiological and pathological mechanisms behind myotonic dystrophies, or DM. To start things off, what exactly are myotonic dystrophies, or DM? Breaking down the term, myo means muscle, tonic means spasm, dys means bad, and trophy means nourishment. In other words, DM is a part of a group of inherited disorders called muscular dystrophies. DM specifically impacts adults and causes malnourished and weakened muscle fibers that consistently contract and do not easily relax. It is an autosomal dominant trait, meaning that inheriting one mutated allele from either parent is enough to cause the disease. And lastly, DM has two forms with both having their own respective histories. First of all, characteristics of the now classified DM were identified back in 1909. Hans Steinert of Leipzig University in Germany, along with Fred Batten and H. Gibb, were responsible for identifying disease as a multisystemic disorder, which is now recognized as the most common form of adult muscular dystrophy. They observed that this disorder involved consistent, rare, and unrelated clinical features, including muscular dystrophy, myotonia, cardiac conduction defects, posterior subcapsular iridescent cataracts, and specific endocrine abnormalities and changes. However, it would take 90 years after identification for scientists to fully understand the disorder's inheritance pattern, epidemiology, pathology, clinical manifestations, and physiological mechanisms. And it wouldn't be until 2000 that both DM loci were fully classified by the International Myotonic Dystrophy Consortium and Online Mendelian Inheritance in Man. Now, what exactly is DM1's pathological mechanism, and how does this cause DM? The genetic basis is a trinucleotide repeat expansion. In other words, the CTG nucleotides are consecutively repeated, and the number of these repeats are dramatically increased in DM1. This repeat expansion takes place on the chromosome 19 locus of 19q13.3 in the tail end of 3' untranslated region of the DMPK gene. This specific tail end region is responsible for the mRNA transcription. But looking at the DMPK gene holistically, it is primarily responsible for expressing the myotonic dystrophy protein kinase, which is normally essential for communication between cardiac muscle cells and central nervous system nerves. The expressed protein is essential for downregulating myosin phosphatase involved in muscle tension, contraction, and relaxation. Normally, the sequence has around 5 to 37 repeats. The full-fledged mutational categorization takes place when there are more than 50 CTG repeats. The sequence becomes more unstable with more repeats, which leads into anticipation. Each generation, this expansion is amplified as children with parents with these repeat expansions will inherit more repeats. It is necessary to note that the exact mechanism as to why repeat expansions cause DM is not fully understood. Now that I've explained what DM and its loci are, and your assignment now is to create a brief elevator pitch video that concisely demonstrates the key differences between DM and DMD. As I mentioned earlier, my TAs Philip and Isabella have filmed an example video contrasting DM and DMD with all the elements I am looking for, excluding one aspect to be mentioned later that you will have to come up with on your own. Please enjoy and take notes. See you all after.
During our time in class, we learned a lot about Duchenne Muscular Dystrophy, and in this project, we talked a lot about myotonic muscular dystrophy. But myotonic muscular dystrophy and a lot of other conditions are very different than DMD.
Now being masters at two unique types of muscular dystrophy, we are going to hone in on the key differences between myotonic muscular dystrophy and Duchenne muscular dystrophy.
First thing to note is that DM, myotonic muscular dystrophy, is most common in adults, ages 20 through 40.
Meanwhile, DMD or Duchenne muscular dystrophy is the most common form of muscular dystrophy that affects children in ages 2 to 6.
DM affects men and women equally.
And DMD only affects boys.
DM progresses slowly as symptoms peak at the ages of 50 through 60.
On the other hand, DMD progresses extremely rapidly. At age 12, they will be unable to walk, and past that, they will need respirators to breathe.
For DM, symptoms will start with weakness in distal extremities, starting with the face, feet, hands, and neck. Individuals with DM have difficulty with muscle relaxation. The weakness manifests in all muscle groups with a delayed relaxation after contraction.
For DMD, symptoms can start in the pelvis, upper arms, and upper legs. Then, it will soon affect all voluntary muscles and muscle movement. This is due to muscle degeneration and muscle wasting.
Both muscular dystrophies lead to symptoms that affect more than just skeletal muscles and their movement.
Yeah, this is true.
When someone has myotonic muscular dystrophy, they're prone to getting cataracts, which is the clouding of the lens in the eyes. More symptoms include gastrointestinal issues like diarrhea or constipation. Myotonic muscular dystrophy can also result in endocrine problems like thyroid issues and diabetes.
Symptoms for Duchenne muscular dystrophy are very different. Someone with DMD is more likely to develop scoliosis, which is a sideways curvature of the spine. Individuals will also have respiratory problems where they have trouble breathing, as well as behavioral and developmental issues.
Unfortunately, both of these conditions lead to cardiovascular problems and affect the heart, but the symptoms manifest in different ways. People with myotonic muscular dystrophy have a weak or abnormal heart rhythm. Some will need pacemakers or a cardiac defibrillator in order to regulate their heart rhythm.
Duchenne muscular dystrophy is also very different. Symptoms include cardiomyopathy, which is a heart muscle disease in which the heart has a hard time pumping blood to the rest of the body. As DMD symptoms continue to progress, the heart muscles will continue to deteriorate. For DMD, achieving adulthood can be possible with proper medical management.
Regardless, we will need more research in order to fully understand and hopefully cure Duchenne muscular dystrophy
And myotonic muscular dystrophy in the future.
Welcome back. I really hope you all enjoyed their amazing video. As I hinted at earlier and alluded to by my TAs, the final aspect that you all have to come up with is the future direction. What are viable treatment methods in research today? For the remainder of this module series, I will discuss current treatment methods and future directions pertaining to myotonic dystrophies, and by extension, other related disorders. After doing so, you will all have the information needed to fully develop your project. It is our hope that you will use this activity to better understand the clear distinctions and similarities between diseases in order to critically think about solutions that precisely target their symptoms and eventually their underlying causes. See y'all in the next lecture.